Dantec's digital media program. And this is a talk about object-oriented publics. And this came out of the question that we're interested in: what does it mean to take computational participation seriously? And by that we mean that computation on its own terms, not as a medium for augmenting or amplifying human agency. We offer an alternative perspective. It's a lens on publics where computation itself will participate directly. And for us, the answer is what we are calling object-oriented publics. In the paper, we build a theoretical case for how computation takes part in the construction of publics. We claim that a public is not just the expression of human desires, fears, and values with regards to an issue. Computation is an actor in these publics and is active in shaping the public. As such, the public also includes the capacities of objects and systems that attend to relevant issues. This perspective offers us two key benefits. First, it lets us move away from the idea that computation is just an appendage to human concerns. Second, it allows us to examine computation as an actor in publics in both how the publics are constituted as well as how they're propagated. And so I'm going to step back for a few minutes and talk a bit about where these ideas have come from. For a while now, publics have been gaining traction as a productive framing concept for design work. The idea of publics as a form of social organization draws on the work of John Dewey. Instead of a single public sphere, he proposes that public life actually contains multiple small publics. These publics are focused on a single issue. A public organizes as a response to that particular condition in order to attend to the consequences of that issue. People might be members of many or few publics at the same time, with each public invested in their own topics and concerns. Bruno Latour broadened the discussion of publics. To Latour, publics emerge from issues as a way to understand how society deals with controversies and dilemmas. From this perspective, issues aren't expected in the abstract. Instead, they are encountered through things or objects. This is what Latour calls an object-oriented politics. Social issues take place through things. As such, publics, via public things, provide a useful bridge to design. And this view has influenced discussions on the politics of artifacts that occur at the intersection of design and STS. It's been taken up by HCI, design studies, CSCW, participatory design, and more. And usually the central concern when discussing publics is the organization of people. Publics contain people, certainly, but not exclusively. Publics are organizations of humans as well as non-humans. They contain animals, plants, atmospheres, buildings, buses, and so on. And we gain two new perspectives by expanding publics to contain computing. First, we find a perspective to understand and interpret the role and impact of computing in social and cultural terms. Second, we find new venues for designing alternative or speculative visions for the future. And this is part of a broader non-human turn, which draws animals, plants, or other living entities into social and cultural analysis. Beyond living organisms, some theorists are looking to understand the roles of objects themselves. So, for example, Jane Bennett's vibrant materialism provides an important connection between notions of material, agency, and political theory. For her, agency emerges from a distributed collective across humans and tools and environments and circumstances. Another way to contribute hybrid agency is through actor network theory. ANT is a perspective from sociology and STS on how actors and objects interrelate within a network. Radical about this perspective is that it grants analytic symmetry between humans and non-humans. And within design studies, scholars have advanced the notion of things. Things describe how built objects articulate relations between humans and non-humans. Binder and N point out that the socio-material thing is also the product of design, and is an attempt to give design a language for imagining and generating networks of effects that include both humans and non-humans. Design things are that combination of object and context, defining a complex network of actors from which agency arises and is enacted. And so integrating these perspectives into the notion of publics creates new opportunities for computing research. This shift lets us move away from understanding computing as subservient to human needs. It allows us to examine how technical artifacts and systems take part in the constitution and propagation of publics. And so the theoretical position opens new territories in two ways that we've found. The first is through analyzing object-oriented publics. In this mode, we take computing artifacts and systems as members of publics, and our goal here is to understand how computing frames and participates in the issues at hand. The second is in using object orientation in a generative way. Generative object-oriented publics take as their inspiration the agency of the artifacts being designed. And so the case studies that follow will help us to describe this landscape of object-oriented publics. Our paper has more, but today I'm just going to talk about two. The first is Psycho-Atlanta, and the second is a tiny tinkering platform. Psycho-Atlanta is an example of an analytic object-oriented public. At its core, Psycho-Atlanta is a smartphone app released in the city of Atlanta. Citizens record their bike rides, upload their route data, ride purpose, and demographic information. City planners then use this data to determine what kinds of cycling infrastructure might be needed for a robust transit system. In addition to generating data about where current cyclists are riding, the project provides a way for public input to enter into the planning process. This input was intended to make infrastructure plans both better and better accepted once it was implemented. So on the left here is a map of routes of interest to planners in Atlanta, and on the right is the ridership data as it was recorded by the application. And the smartphone app channels two utopian threads about how digital technologies can transform public life. The first is the vision of the smart city. This is the idea that sensor networks, instrumented infrastructure, participatory sensing might combine to improve city services and planning. And the second draws on the idea of digital democracy. Here, public participation in governments is decoupled from existing physical and temporal constraints, like attendance at public hearings. And these projects integrated the two perspectives by linking data collection with democratic participation. Citizens' phones became sensors to generate new streams of data for urban planners. The act of sensing bike routes became a form of advocacy for new infrastructure. This took the place of the public meetings and design threats where that advocacy usually occurs. But the app also did more than augment how cyclists participate in the urban planning process. The mere existence of the app enacts a set of political realities. It lets the city position itself as a progressive, data-driven, and technology-embracing place. It carries rhetorical weight for elected officials as well as for citizens. At the same time, it positions the app as a material participant in the democratic process. The app also did more than amplify cyclist participation in policy or infrastructure discussion. The app acts as a member of a public that has unique relationships to various stakeholders involved. Some of these relations come through use, so the communities using the app provides a representation of geography and mobility that solidifies existing socioeconomic boundaries in a both empirical and authoritative way. But other relations come through non-use. So here, issues of community identity, gentrification, race, and class become viewed through the lens of database participation. In some instances, the app participates just by means of existing. This is a map of census data plotting race in Atlanta, for example. And it's very worth mentioning that the areas of low or no ridership occurs in already underserved majority African-American communities. Even further, in planning meetings, we observe planners and engineers refer to data that might be collected by the app in the future to justify planning decisions in the present. In this case, human participation was inferred. And in version, humans were positioned as augmenting the technology. The app, rhetorically being an element of the near future smart city, enabled new political and policy claims to be made, even without people. So the analytic mode seeks to understand how computing frames and participates in the issue at hand. We argue that the Cycle Atlanta app and the data both take part as members of a cycling public. Through this participation, issues arise like equity and participation, veracity and representation, and accountability and transparency of civic institutions. These issues are all bound up in the human and non-human composition of the cycling public. The application and data combine as a thing that enables an alternative means of contesting urban planning. And the second example is one called the Tiny Tinkering Platform, where the idea of an object-oriented public can be used to generate new design opportunities. And so the Tiny Tinkering Platform is built to critically interrogate the Internet of Things. The IoT is comprised of many parts: people, technology companies, privacy concerns, corporatism, upgradability, marketing cost, infrastructure, and computation all play a part. I mean, this might go without saying, but the Internet of Things is an Internet of designed things. Far from being neutral, the devices and systems that comprise the Internet of Things generate a socio-material assemblage that has agency. And so participation in the Internet of Things might begin with a person buying a smart thermostat or a smoke alarm, but it also includes a recognition of how the smart item is itself participating. Each of these reflect computational assumptions reflecting choices made in their design and manufacture. The IoT is an arrangement of human and non-human computational agents that take part in the daily life of the home. Algorithmic assumptions about what might happen at a given time, sensing standards that learn habits from the owner's everyday patterns, seamless integration into larger systems extending outside of the home. These exert forces that are not obvious, and their implications are often made unclear to the users. And so, as a response, we designed a tiny tail prototyping platform for an alternative IoT. This IoT is bottom-up rather than centrally controlled. It puts an emphasis on material, computational, and human collaboration rather than parameterizing the everyday world to be understood by central authority, and it does not require the internet. We use this very simple prototyping platform to explore building barely smart materials in the home. We focus on using the cheapest, most minimal hardware components to create a very basic design mentality, where the microcontroller, electronics, and software become integral parts of an elemental tool to examine materials. It supports different kinds of input and output based on standardized sensor connections from a retail kit. These sensors in the platform can be used to build minimalist indicator for a variety of conditions. When hot coffee might have reached the right temperature to drink, where a plant needs watering, if a mail has been delivered, whether it's cold enough outside to warrant wearing a jacket, or a trigger that automatically lowers the blinds when the sun is hitting the room in a certain way. It creates a venue for a computational public that's focused on reducing complexity and ubiquitous sensing. In these scenarios, the computational constraints help to generate new kinds of material arrangements. It also helps to materialize the experiences that everyday objects have. Instead of being controlled from a cellular phone or personal computer, our platform instruments the everyday. Here, tiny situations and conditions let everyday objects become partners in ubiquitous meaning-making. Publics like this vary according to the size and scale of their projects. The Tiny Tinkering platform is an example of how a computational system might generate new publics and foster new experiences of doing computation. The platform assumes a particular orientation towards computation. By restricting the capacities for expression, the platform creates a public with a distinctive aesthetic approach, one committed to and organized around a certain kind of material minimalism. So in the preceding cases, we describe how computing plays an active role in the constitution of the public. This requires that we recognize and appreciate that publics are not solely made of people, and that to understand the formation and activities of publics, we need to take into account the agency and material capacity of computation. Usually, discussions of politics are centered on civic institutions or mechanisms of government. Political engagement usually means working with political parties, government agencies, or civic organizations. Most political projects tend to contribute towards organizations like these. Framing politics in this way does not take into account the agency and effect of computation in those arrangements. For instance, the data generated by Psycho-Atlanta is a political entity. These data cohere a public by providing a unifying organization to a range of human actors and their actions. The data collected are not only traces of individuals. Together they aggregate a bundling of those actors and a binding of them to an issue. The data and algorithmic analysis of those data do even more, though. They become constituents in a cycling public. They are actors that need to be taken into account on their own terms and recognized for their potential to affect change in themselves. Taking computation seriously as an actor in publics might at first blush seem counterintuitive, especially at an HCI conference. But claiming that computation is a political actor is not asserting that an algorithm or data exerts authority over a person. And we don't mean to embrace a kind of technical determinism. Instead, we see this as a way of acknowledging how the capacities of computation figure into the constitution of a public. The second way we want to interpret the agency of computation is through the influence it exerts on creative endeavors. Computation affects the formation and support of publics oriented around modes of imaginative production. These agencies are not political agencies, but rather creative ones. Making, for example, is an increasingly important site for design research. Attending to the material qualities of computation provides insight into how publics might form to address the issues and opportunities of making. As a speculative gesture, the Tiny Tinkering platform becomes a member of a public concerned with how activities of making are being shaped in relation to dominant discourse around innovation. Like Psycho-Atlanta, the design of speculative platforms intends to both cohere a public through its agencies as well as to become an actor in that public, contributing to providing an alternative practice. Understanding computation as an actor that shapes creativity does not lessen creativity. It simply extends a line of thinking with regards to how materials shape expression. The agencies extend beyond the shaping of expression to the object or system to shaping the community that comes together to explore the inventive opportunities of computation. In these publics, computation is not just the subject of inquiry. It also acts to structure expression both by its capacities when it's present, as well as what it thwarts in its absence. And so, the main takeaways of this paper about object-oriented publics are a way to both think about how computation participates in publics, is oriented around issues, and takes place via things. Computing is more active in our social worlds than we usually assume. Computation plays a part as itself, and not just as a venue for human intention or plans. And this perspective offers two key benefits. First, it lets us move away from the idea that computation is an appendage to human concerns. Second, it allows us to examine computation as an actor in publics in both how they're constituted as well as how they're propagated. We feel that this approach is helpful for both analyzing existing systems in the world as well as for design approaches that generate new objects and systems. Thanks.
We have time for some questions if people want to come to the mic.
Very high. Thanks so much. Super interesting. I just had a question about sort of agency. You're framing computation. I mean, just more of a clarification. Like, you're framing computation as having agency, but then the things that you're showing us are kind of things that I would consider artifacts of computation. So if we're thinking about like the output, the visualization of a participatory bike riding project, like computation feels like a verb. Right? And like those things are things. So I don't think of computation as being a thing, but maybe you can.
Yeah, I can try. I mean, I think to my mind, there's an outcome from these sorts of computational artifacts that itself is distinct from the thing or the use of the thing, right? There's this kind of aggregated effect of computation in society. Is that closer to?
Maybe. I mean, I guess I was just wondering if you think that verbs are things too. I guess that's the question.
I certainly think they are.
Or just things.
Chris from Virginia Tech. Correct me if I'm wrong, but you said that part of all of this ecology is that it makes things easier for the community as a whole and less complex by having all of these objects?
No, I think that what we mean is to say that this is a way of trying to examine how artifacts might operate in the world more aggressively than we might usually expect, and that able to interpret this kind of cumulative effects as being more perspective than we might otherwise look at them.
So you weren't addressing the complexity of it?
The complexity is part of it, but ease is also, I mean, like this is, it's.
And you say it's easier?
No, I say it's an analytical tool.
Okay. All right, then that'll clarify that.
I'm going to do a crosstalk question while people are maybe gathering their thoughts. Jessa made the decision to go extremely not computational, but technical in the STS sense. Where do you see connections between you maybe having gone the other way, or what do you see crossovers there?
Yeah, I do. I mean, I was really fascinated by your talk. I thought it was great that we were kind of talking about the same thing in different perspectives. I think part of the intention of trying to take into account computation as sort of a social actor is to draw away the assumption that what we think of as sort of high technology is in some way a tool for our own services and desires. So if we think about high technology as embodying a certain sort of social agency, we can think about what kinds of autonomy and perspectives it might bring to the table.
So I have a question related to your use of the word ecologies, because it's very tempting to look at the assemblage as an ecology, as something that can, but that word also has a couple of connotations. One is that it's sort of natural, it develops naturally, it has a balance, it is something good in some sense. Where do the political perspective come into this? Because this is also the development of the Internet of Things is very much driven politically as well. So I wonder, why do you choose the word ecologies in particular?
I think I like it because it invokes those sorts of politically oriented concerns, but then doesn't come to fruition in that sense. Like, I think I like it as a provocation to think about how objects and devices and systems might work in concert in ways that are kind of unknowable in their outer reaches. So I think it's, for me, a metaphor that I find provocative to consider cumulative relationships via.
Let's go ahead and give Tom another round of applause.